To our research instructor, Dr. Craig Rifuyo, to our panel, Dr. Jean Haff, Dr. Leah Haff, and Dr. Jocelyn Kong. This is our research proposal entitled Standardization of Science Laboratories for Science Teaching in Public Senior High Schools of Dumaguete City by Mr. Harley Partosa and Ms. Mary Queen AUSEJO. For the introduction, science teaching is a crucial process. This requires laboratory activities or experimentations, and a lot of science activities are better done in the laboratory, wherein students can manipulate equipment or apparatuses to practice independent learning, improve critical thinking, understanding, and inferring. Experimentation involves hands-on learning. Students obtain better results in their academic development when science is taught through hands-on experiments. Kolb's theory of experiential learning includes learning as a whole process and that learning can be acquired through experience or hands-on learning. Experiential learning program improves the clinical reasoning and critical thinking skills of students. The challenges that laboratory facilitators or science teachers are facing is the lack of equipment for laboratory use. Laboratory shortages corresponded with poor performance and high dropout rates. There is a limited number of apparatuses for several students, and moreover, laboratory materials such as chemicals would always come to shortage. In public schools, the number or population of students in the classroom would range higher. Due to the lack of resources, student grouping is done where there is higher number of students assigned in a group. It always happens that only a few could be given the chance to learn, and there is an equal opportunity given. This means that a larger group could only utilize a limited number of apparatus, providing limited opportunity for other individuals. This compromises the learning of students where there are lesser engagements and lowering of interests. For the statement of the problem, this research aims to assess the skill level of science teachers in terms of laboratory techniques like apparatus handling, chemical handling, laboratory management, and standardizing the number of each of the basic apparatus in science laboratories of public senior high schools of Dumaguete City. This study seeks to answer the following questions. Question number one, what is the profile of the science laboratory teacher in terms of the following? 1.1 age, 1.2 sex, 1.3 area of specialization, 1.4 years in teaching, 1.5 workshops given to or experience in terms of science laboratory management. And then for question number two, what is the level of experience of the teacher in terms of the following? 2.1 chemical handling, 2.2 chemical disposal, 2.3 equipment or apparatus handling, and 2.4 is laboratory management. For question number three, what is the number of basic apparatus in terms of the following? 3.1 test tube, 3.2 Bunsen burner, 3.3 iron stand, 3.4 graduated cylinder, 3.5 Erlenmeyer flask, 3.6 Florence flask, 3.7 thermometer, 3.8 tripod, 3.9 beaker, 3.10 triple beam balance, and 3.11 is the microscope. For question number four, what is the standard number of each of the apparatus to consider a laboratory to be ready for use? And question number five, what are the challenges encountered by the science teachers in terms of teaching or facilitating the science laboratory? And question number six, what are the improvised laboratory apparatuses present in the school science laboratory? So these are the questions that we aim to answer in this research. For our conceptual framework, this study will be utilizing a survey questionnaire to get the desired data that will be analyzed to design certain standards on laboratory techniques. The laboratory performance will be analyzed through the skill or experience level of the teacher, and that the number of apparatuses in particular schools will be measured. The results of this study will be utilized as the basis for standardization. For easier understanding of our framework or conceptual framework, so we have here the chart. For our theoretical framework, experiential learning theory by David Kolb is one of the best known educational theories. This theory uses a cycle presenting a way of structuring sessions or a whole course. The stages in a cycle has a unique and distinct learning style. According to Kolb, learning is a process whereby knowledge is created through transformation of experience. This presents a way on how curriculum instruction should be structured to improve the grasp of information in students and teachers must identify their own learning style to identify an effective learning and teaching strategy. In the Learning Theory in Education by Bruner, in Discovery Learning, he proposes that learners construct their own knowledge by organizing information through coding system. He said that developing a coding system is better discovered than being told by the teacher. This is also explained in the theory of constructivism. One of the key features of laboratory activities is discovery learning, wherein the students are to perform the experiment and discover answers by themselves. Moreover, like Brunner, Vygotsky emphasized the social nature of learning, that a more knowledgeable other can help the child or a learner develop skills through scaffolding. In science laboratory setting, the teachers scaffold and assist students in their task. With this, it is important that the teacher is well equipped. For continuation of the presentation, let's have Miss Mary Queen Osejo.
Let's go now to our review of related literature. There are a lot of changes in education, and these are the lack of compensation for teachers' professional development, insufficiency on the number of teachers in science and technology to prepare programs, science teachers lack training, the lack of motivation and confidence of students, achievement gaps in science and math, demographic changes, larger size of classes or huge number of students in class, lessons that has broken link, less laboratory opportunities or insufficiency in physical conditions, and insufficient time allocations for lessons in science. Now, according to Peng Wai Kyok in 2015, stated that teachers are willing to provide a learning environment for investigative type of approach, but no action was given in this claim or respect. They have concerns about discipline, safety, large class size, laboratory support, management, and examination-oriented culture. The solution given to this are involving increase in the amount of teaching resources and change in management practice, which is influenced by culture. The K-12 science curricula in the Philippines is a learner-centered and inquiry-based discipline requiring learners to make use of learning materials and learning spaces needed for understanding of the scientific concepts and for developing their scientific literacy or skills. This is anchored on the constructivism theory that supports learning by doing. A laboratory is an important and crucial place for active learning and science teaching that would provide students to think creatively and critically to solve real-world problems. Many public schools in the Philippines are challenged by the lack of science laboratory facilities and equipment, including learner materials. With this situation, science teachers resort to skip and not do laboratory activities if improvisation is not possible. That may hinder achieving some competencies needed by the learners. Now, according to Kolb's learning theory, it presents a way on how curriculum and instruction should be structured to improve the grasp of information in students and teachers. The stages in the theory of Kolb are concrete experience, which is the basis for the learning process, reflective observation, students learn by experience and by articulating, abstract conceptualization, relays observation from the reflective observation stage to the subjective concept. Active experimentation wherein students perform and test theories to create predictions about reality. The class size is one factor to consider when evaluating the effectiveness of a school. Education researchers have found that the reduction of class size in early grade helps students achieve because there is a greater opportunity for individual interaction between student and teacher in a small class. The country's public elementary schools average class size of 43.9 is far bigger than Malaysia's 31.7, Thailand's 22.9, Japan's 28.6, and India's 40. In public secondary schools, the country registered an average size of 56.1, higher than Malaysia's 34, Thailand's 41.5, Japan's 33.9, and India's 39. Further, oversized public school classes not only deny Filipino children's quality education, but also deny teachers just compensation and humane working conditions. We have here the basic apparatus, which are the beaker, boiling tube, burette, condenser, conical flask, desiccator, and filtration flask, flat bottom flask, funnel, gas jar, measuring cylinder, flat bottom flask, petri dish, pipette, round bottom flask, separating funnel, test tubes, volumetric flask, watch glass, Bunsen funnel, Bunsen burner, burette stands with restored clamp, ceramic gauze, cork brewers, evaporating basin, filter pumps, Kodge crucible, Moore clip, pipe clay triangle, pipette fillers, pestle and mortar, retort ring, spirit lamp, spatulas, test tube holder, test tube rock, tongs, tripod stand, and wash bottle. Let's go now to our research design. This research follows a descriptive and survey methodology. A survey questionnaire is given to the different senior high school public schools of Dumaguete City. This will be using census wherein all public senior high school science teachers in Dumaguete are involved regardless of division. The copies of the questionnaires are stated in the English language. The respondents are the science teachers who handle science laboratory. This has two parts. The first is a demographic profile and a 5-point Likert scale composed of statements on laboratory skills, techniques, and challenges faced by science teachers in handling laboratory activities. The second part is a table that will be asking for the count or frequency of each of the basic apparatus found in the school science laboratory. The questionnaires will be then gathered by the researchers and answers will be interpreted and analyzed to derive on a set of standards to be followed specifically on the number of apparatuses present in the school science laboratory and a manual on laboratory technique. To gather desired data for this research, a survey questionnaire will be used. The questionnaire is composed of survey questions to assess the respondents' knowledge on laboratory techniques and a survey on the number of apparatuses present in the school's science laboratory. The questionnaire is composed of two parts as stated in the design a while ago. Now for our research environment. This research will be conducted within Dumaguete City, Negros Oriental. The focal point of the study will be Negros Oriental State University. The schools that will be included in this research are Negros Oriental High School, Dumaguete City High School, Piapi High School, Dumaguete City Science High School, Hunob National High School, and Kamanhak National High School. The participants or respondents of this are the public senior high school teachers who teach science or science laboratory facilitators from Negros Oriental High School, Dumaguete City High School, Piapi High School, Dumaguete City Science High School, Hunob National High School, and Kamanhak National High School. For our data gathering procedure, The questionnaires will be given to the respondents of a different public senior high school in Dumaguete City. A specific time span shall be given to them in answering the questions. After a given time, the researchers will gather the data from different schools. The data will be then analyzed and interpreted. The results based on the data will be used to create a standard manual or guide that will be used by the respondents or the school to maximize the use of laboratory. Laboratory improvisation and techniques will also be included in the guide. Let's go now to our statistical treatment. A 5-point Likert scale will be used for the first part, measuring the skill or experience level of the science teacher and the agreeability on the different challenges encountered in the laboratory. The data of quantitative research questions will be treated with descriptive statistics, which demographic information is also integrated. The second part will be treated with a t-test comparing the standard number of each apparatuses with that of the number of apparatuses found in the school's laboratory and the significant difference between groups. The standard number of apparatus will be set and identified by the researchers. This will be based on the average number of students in the classroom in the Philippine setting. And here are our set of references that we use for our readings and basis for the different researches or study that we had.